Hello friends, hope you are having a fantastic day today. So now we are going to solve an awesome LeetCode problem that has tons of practical use cases. We are going to solve a problem called cheapest flight within K stops, and all the travel companies and airlines uses the logic we are going to solve in this problem. So this is a really important and informative problem with lot of useful properties. So basically in the problem statement we are given n cities that are connected by some flights, and we are given an array called flights where we have three values. We have the source city, we have the destination city, and we have the price it takes to get from like the source city to the destination city, and we are given bunch of entries like this. Now we are also given three additional integer called source, destination, and k that defines that we want our travel to start from the source city and at the destination city, and k is the maximum number of stops we are allowing ourselves to take, and our aim is to find the cheapest tickets that we can find within the constraint of given k stops from source to destination. And if we can find the cheapest ticket, that's great, we need to return that value. If we cannot find any tickets, then we need to return -1. So let's try to understand this problem with a real life example. So here I have given bunch of different values inside our flights array, and we also have three different values called source, destination, and k. Now we can see that every single entry inside this array contains three values, and we all know that this defines the source city, the destination city, and the price it takes to reach to that particular destination city. We are also being told that we are planning our journey from source city 0 and destination city 3. Now this 0 and 3 can be replaced by any real life values like New York and Paris, France, New Delhi, you name it. And we are saying that we want to take at most one stops, nothing more than that. And now let's try to see that what is the amount or what should be the answer in this case. So I have drawn the whole information that we have provided in this flights array in this beautiful graph like description. And now we can see that we are starting our travel from city number 0, and we need to reach to destination number 3. Now we can see that one route is that we go from 0 to 1, and then once we reach to stop number 1, this would be our first stop, and then from 1 we have to go to 3 because we are only allowing ourselves to only take just one stop. Now from 0 there are no other stops that we can take in order to reach to 3, so this is the only path that we are allowed to take within the given constraint, and the cost to reach to city number 3 in this case is going to be 100 plus 600, so in total 700, and this is what we need to return as the answer. Now say for an example, in the same scenario, instead of k being 1, if we are given the value k being 2 as allowed to be given. Now in this case, let's see the scenario. First stop we can take is that from 0 we can reach to city number 1. This is going to be our first path. Now from the city number 1 we have two options. One option is that we reach to city number 3, that gives us the answer that we can reach to the destination within $700. But the other option is that since we are allowed k to be 2, we can take one more intermediate city as a stop, and we decide to take a stop at city number 2. Now in order to reach to city number 2, it takes $100 plus $100, so $200 to reach to city number 2. And from city number 2 we also have a direct connection to city number 3, and that is also going to be adding the cost of 200. So it takes 200 to reach to city number 2 and plus 200 more to reach to city number 3, so in total it's going to be 400. So in this case the cheapest flight would be 400 that we can return as part of the answer if we are given our k to be 2. So this is what we need to return in this example. Now the first logic that comes to our mind is a very simple brute force approach, where logic is going to be quite straightforward, that we go through every single possibility of all the nodes that we can visit and all the edges that we can visit, and then try to see that what is going to be the cheapest price to reach to the city number 3. In order to do that, we can actually use the graph based representation of this given input flights array, and after converting it into the graph we can actually do like breadth first search or depth first search from any particular node for all the other subsequent nodes. So we are iterating over all the possible edges and recording the values. We can also use backtracking, recursion, you name it, in order to solve this problem. The thing is, uh, that solution would be okay in terms of like coming up with just a solution to have. But the thing is, think of the real life scenario. We are dealing with hundreds or millions of cities, flights, and costs. So that's not a scalable solution. We need to find a better approach. And that's where a beautiful solution or algorithm that comes into the picture, and that is called Bellman-Ford algorithm. So now let's see that how can we utilize this algorithm to solve this problem. So once again, we are going to be using the same example to solve this problem using the Bellman-Ford algorithm. The logic is quite straightforward. We are actually going to be focusing on the only thing that for every single k iteration, how much time it takes to reach to any particular destination city and what is the cost associated with that. And in the end, for all the given k entries, we will keep on running the same process until we reach to the end that we are looking for. And then if we found any particular cost for the associated destination city, in this case we have value number 3, then we can return that. If that is not the case, then we can return -1. So let's try to understand the logic I'm suggesting to solve this problem. For that, we are actually going to be using some sort of placeholder values where we can store that how much time it took or how much money it took to reach to any particular destination city. For that, number one thing we need is to have an array called cost that defines that in order to reach to any particular destination city, what is the cost associated with this. Now the second layer of complexity in this case is value of k, because notice that in our one of the examples we saw, if we only have to make one stop, then we come up with a different cost. But if we are allowed to use two stops, then we are able to come up with a different stop or different cost. So once again, we are going to be using the same logic. And in order to justify the value of k, if we, in order apart from using this one, we will also have to use a temporary array for every single value of k. So now let's try to understand the logic I'm suggesting. Currently I have defined an array called cost, and we are going to be seeing that in order to reach to any particular destination city, what is the cost associated with this one. This is the number one thing. And second one is this temporary array would be reset for every single k value. And once we calculate that how much time and effort and money it took to reach to any particular destination city around any of the k iteration, then we are going to be copying this temporary array to this cost array and repeat the same process for the upcoming subsequent k values. Now in this case, let's say that for first we are going to be calculating that what would be the logic for k is equal to 1. Then we will see that what would be the logic for k is equal to 2. Okay, so let's stay with me. This is going to be pretty interesting to understand and learn the whole process. Now we don't know that how we can define that whether we have a city cost associated that is cheaper or not. In order to do that, what I'm suggesting is that initially I put the cost to the maximum value possible, and after putting the cost to the maximum value possible, whenever we find some value that is smaller than the current value, then we update that value, because it is in our benefit to update the cost it takes to reach to that destination city. And now let's start our process. Now we know our source city is 0, so by default, logically, in order to reach to city number 0, the cost has to be 0 because we are already there. That is our source city. So we are going to be checking, first of all, updating that value inside our array. So for city number 0, currently it takes maximum value to reach to that particular city, but we are going to be defining it as 0. Okay, and now we are starting our process. So we are going to go through edge by edge for every single array. We are going to be updating the temporary value for that kth element, and then temporary array is going to be flipped over to the cost, and then we are going to repeat the same process. So currently for the temporary array, we are going to take a copy from the cost for this first iteration. So this is 0, and all of these are max in order to reach to any particular city. Now first thing is that in order to reach to city number 1, it takes us $100. So we are going to be updating that information, that in order to reach to city number 1, it takes $100. But the thing is, first we are going to check that the source city that we are traveling from, that already has some value and it is not the maximum value. Because if any particular city has the maximum value, that means that that city is not reachable. So if the source city is not reachable, how can we reach the destination city from that source city? Now in this case, source is 0 and destination is 1 and the price is 100. So we already know that we can reach to the source city because this value is 0 inside the current array. So then we are going to be updating this one as 100 because it takes $100 to reach to that particular city. Next thing is, in order to reach to city number 2, it takes $100 from city number 1. But the thing is, in our original cost array, we cannot reach to city number 1. So once again, for this one, we should not be able to reach to city number 2 as well, because city number 1 is not reachable. So notice this is going to be for k is equal to 1, only one city. So we can only make one stop, so that is this stop. And if we, so that's it. So now next thing is, in order to reach to city number 0, the cost is 100 from source city 2. Once again, for 2 source city 2, we cannot reach inside the cost array, so we cannot update any value. And also in this case, this would not be updated because currently in order to reach to city number 0, the cost we have is 0 and this is 100. So why would we pay higher money if we already have a lower value? So this would not be used. Next value is, in order to reach to city number 3, it takes $600. The thing is, we cannot reach to city number 1. So currently, and notice that currently we are iterating over k is equal to 0 and we have maximum value of k is equal to 1. So we are going to be running this iteration twice. So currently for k is equal to 0, this one is from 1 to 3, it takes $600. But the thing is, we cannot reach 1, so we cannot reach 3. Once again, next iteration, we cannot reach any other city because 2 to 3 is 200, but we cannot reach 2, so we cannot reach 3. So these are also going to be blank. Now notice that after the first iteration, we only traveled one city, that was the immediate neighbor of this node number 0. And this is the whole point of this exercise, that every iteration we are going in like breadth manner for all the cities that we can iterate over, and we are updating the cost accordingly. Now for the next k iteration, we also need to update the value of this temporary value inside our current cost array. So first we will update this one. So this is going to be 0, 100, and then these two are going to be max value and max value. And once again, we are going to be starting with a blank temporary array, but we are going to take the copy of this cost array. So this is also going to be 0, 100, and then max value and max value. Now let's see the same iteration again. Now 0 to 1, 100, we already have this value stored, so we don't need to update. 1 to 2, 100. Now in this case, we are able to reach to city number 1 with 100 cost. So in order to reach to city number 2, the cost has to be 200. So we can update this value to be 200. And notice that this time we are iterating over for k is equal to 1. We initially started for k is equal to 0, and now we are going to keep on repeating the same process. Now next thing is 2 to 0, it takes 100, but we don't need to update that because in order to reach to 0, we already have the value as 0. Next one is 1 to 3 as 600. Currently, in order to reach to 1, we have the value 100. So we can reach to city number 3, and 1 to 3 is going to be 700. So we are going to updating the value as 700. And now next thing is 2 to 3 is 200, but we cannot reach 2 in this case because cost array is still showing 2 as maximum value, so we are not able to reach this one, so we are not going to be considering this edge. And next thing is, next would be the k is equal to 2, but the thing is, notice we only have k is equal to 1 as max. So the moment we are done with this one, we will break out of all the loops. And sorry, before this one, we are actually going to updating the temporary array to the cost array as well. So now inside our cost array, we will have a couple of more entries. So in order to reach to city number 2, it's going to be 200, and in order to reach to city number 3, it's going to be 700. Now after this one, once we end our loop, we are going to be checking our cost array. We are going to be seeing that if the destination city is 3, and if this value is not maximum, then whatever value is, we need to return this one. So our answer is going to be 700. And if we cannot return 700, like if the value would have been maximum, then we would have written -1. Now let's take one more example for k is equal to 2, just to solidify your understanding. Once again, 0 to 1 100, we already have updated this value. 1 to 2 100, we also have updated this value as 200. 2 to 0 as 100, we don't need to update this one because we have 0 as 0. 1 to 3 is 600, so this has also been updated. And next value is 2 to 3 is 200. So this value, we can see that we are able to reach to city number 2. That means we can reach to city number 3. The cost is going to be 200 plus 200 400, but the current maximum cost to reach to that particular city is 700. So we need to remove 700 with 400, because now we can reach to city number 3 with 400 cost. And now, since this is k is equal to 2, once we are done with our loop, we will update this value over here. So this becomes 400. And then in the end, if we have to return the answer, we can return 400. That after with k is equal to 2 stops, we can reach to city number 3 in 200 cost. So imagine, see how beautiful the solution is. And now I hope you understood that what we are trying to do over here. If we have to calculate the time and space complexity, it's quite obvious that for k times, we will have to iterate over all the given edges that we currently have and all the given nodes that we currently have. So it's going to be k multiplied by the number of nodes and edges, so O multiplied by V. uh, so yeah, and this would be the time complexity. And if we see space complexity, we are using couple of arrays to store the values. This is going to be the temporary storage and this is going to be the constant storage, but both are dependent on the number of cities. So let's say if the number of cities are the number of nodes, so it's going to be big O of n, where n defines the number of nodes. And this is the whole solution. Now let's quickly see the coding solution for this one. So the coding solution is actually quite straightforward. First, we are going to initialize our cost array. Then we are going to be filling the cost array with the maximum value possible. Then we are going to define that in order to reach to source city, it takes us 0 amount. So we are going to mark it as 0. And then we are going to initialize our two loops. First loop is only going to run from 0 to k value, where we are going to be starting a temporary array, where that is going to be the clone of our cost array that we have created so far. Next, we are going to be iterating over every single edge. Now for this edge, first thing we are going to be doing is defining the value of u, v, and the cost to reach to that particular city, where u is the source city, v is the destination city, and cost defines that how much money it takes to reach to the destination city. The values are extracted from our flights input array. Next, first thing we are checking is that in the original cost array, if in order to reach to city u, that is the source city, is maximum value, that means we cannot reach source city in that kth iteration. So we need to continue that operation. If that is not the case and we are able to reach to the source city, then we are checking that in order to reach to the destination city v, what is the current cost we have. And if the current cost is actually greater than the cost we are able to achieve using the cost it takes to reach to city u plus the current cost for the based on the current edge, whichever is the smaller, we are going to be keeping that value inside our temporary array. And once we are done iterating over all the flights for that kth iteration, we are going to be copying the temporary array inside our cost array and repeat the same process for the next kth iteration. In the end, the answer is quite straightforward. We simply need to check that if the cost to reach to that particular destination city, if that is the maximum value possible, then we need to return -1. If that is not the case, whatever the cost value is, we can simply return this one. And this is the whole solution. Look how beautiful it looks. Now let's try to run the solution. Seems like it's working as expected. Let's submit this code. and our code runs beautiful. It beats almost 97% of all the users, which is pretty awesome. And I would be posting this solution inside our GitHub repository, so if you want, you can go ahead and check it out from there. Thank you.